start here the recording. Hello, everyone, and welcome to this CIA bootcamp. My name is Davis Altamirano. I am based in Costa Rica, and I have been with the Zscaler team for a little more than 5 years, almost 6 now. Initially as a technical account manager, and within the last few years with the enablement team, helping delivering these CIA, CPA boot camps for internal and partners, and overall developing all of these trainings through the last couple of years with the help of all the enablement team, of course. And during this week, we'll be going into CIA. We'll be talking about the architecture, traffic forwarding, and the policy enforcement of CIA. So in general, the idea is that during this week, you go through a deployment experience of basically what needs to take into account at a quite basic level for many things, and as the scope of what this type of support will have, right? And overall, hopefully getting for you to understand or get together some concepts that you may have seen during other Zscaler certifications. Hitesh, not sure if I'm missing anything.
Yep, no, Davis. Everything you have covered. The only thing is that we have some labs related to the boot camp, which is very important. So for those labs, we will be providing you a lab environment called SkyTab. So I will be providing you those credentials by tomorrow, as I will be getting the credentials from the lab admin team. Once I will get those, I will share with you all through email. And then Davis can show you how to configure the SkyTap environment, and then you all can do the labs there. I think you all will be getting the lab environment only for 2 weeks. So please try to complete all the lab exercises before that. And after that, it will be auto deleted. And second thing is regarding attendance. So please try to maintain 80% of your attendance each day. So as the session is spread across 5 hours, so try to be there for at least 4 hours. And there will be breaks also during this 5 hours. Davis will tell you about that. Yeah. So what do you, Davis?
Absolutely. Awesome. Thank you. Thank you so much, Hitesh. Yeah, we have a 5 hour session for 5 days. So usually I try to get us a break about after an hour and a half or so, right? So that way we can have a little bit of breathing time in between exercises. We may have a few exemptions, right? Sometimes we can maybe take a little long or less with some of the exercises. So again, we can always adjust according to everyone needs, or at least the majority. We have quite a big team or a lot of people for this week. So it's going to be fun. And of course, we're going to have to make sure that we can all basically stay within the session as much as possible. Now, that being said, as Hitesh was saying, you guys will be provided with actually two sets of credentials. One is going to be access to a virtual environment. Let me share my screen here, and we'll go over here. There we go. So you will be provided with a similar environment like the one you're seeing, maybe with a few less devices, but overall, you'll basically going to have a Windows machine, a Linux machine, and most likely an NSS server and an AD server. But the two most important devices that we'll be using during the week is going to be a desktop devices, one Linux, one Windows, which will help us create things like IPsec tunnels. Will be able to connect with multiple traffic forwarding mechanisms using the client connector and test out proxies and how they behave and what's the differences between all of those, right? So this will be our end clients that will be connecting to the cloud, right? Then we'll be providing you all with access to a CIA account. That'll be a cloud instance from Zscaler 2, if I'm not wrong. That once again will be for just these couple of weeks. And you will be having that as a way to manage the integrations for things like SAML, and also to configure the users, to configure policies, and once again, to define all of these traffic forwarding mechanisms. So once again, lots of fun, lots of hands-on, hopefully. I try to make it as interactive as possible. Of course, we still have quite some lecture to go through, because we need to go over first the understanding and the overall traffic flow of the communications and the nodes involved. But hopefully we can make a good mix of both of them. Now, before we begin, I'd like to also check if there's maybe any expectations from the session or any particular questions that you have before we start during our 40 class.
Just looking to see what we can expect to get different out of this class versus like the EDU 200 and 202.
Gotcha. Yeah. Mainly our main focus is try to see it from a troubleshooting perspective, right? Beyond just understanding what this does or what policies will do this or that, it's mainly about how do I approach these scenarios or these situations in a customer problem, right? Mostly it's what all this is all about, right? That's why you go through the whole deployment. So you will be configuring the proxies, and you will experience basically what a client will see when things are not working and what to look for on that regard. So that's kind of like the main difference between this or that.
Well, it's more real life.
Are we
Go ahead, Praveen.
are we covering Zscaler firewall and DLP modules, or it is only the proxy module itself?
We're gonna go through firewall module a little bit, and if we have the chance, we may do some DLP exercises on day 5. But the main focus of this week will be about traffic forwarding, user authentication, and policy enforcement, mainly URL, cloud app control, and SSL inspection. That's kind of like the core of this week. Beyond that, we can branch out and maybe go into some more detailed ones. But yeah, that the main priority will be those. All right.
Yeah.
But if there's something specific about DLP, by all means, let me know, and we can try to squeeze any demo or any conversation about that for sure.
So Davis, I'm very much keen to know the traffic flow, how the tenants are going to process the traffic in case when we are using both ZIA and ZPA. So
Absolutely.
I just want to know how they're just going to resolve the DNS traffic, and how they are just come to know that this traffic is meant to go for the cloud, and this is the traffic that is meant to go via the private access. So how they're going to differentiate that what request that needs to be forwarded to which tenant, or where it should be forwarded.
All right. Well, we mainly focus just on the CIA part of that communication, but I'll definitely can give you some pointers about the difference between CIA and CPA, because it's actually easily identifiable depending on the traffic forwarding mechanism that we have. But yeah, we're definitely gonna go into some of those details. In today's class, we'll go over the traffic flow information, right? So we'll see which nodes talk to what, and basically what happens when the traffic gets into the cloud. All right. So yeah, absolutely. Thank you guys for sharing that. Anything else from anyone? Any other either questions, comments, anything in particular? All right, guess we're good. Okay, team. So let me see. I did share, not yet. Let me put it there on the chat now. I'm sharing a file, which is basically the slides for today's session. On a daily basis, I'm gonna be sharing these on the chat, as well as any other attachments that might be necessary. And at the end of the day, a couple of hours after the session ends, I'll be sending also the recording, because it takes a couple of hours for Zoom to get it done. So I'll be sending the link with the recording, with the slides for the day, and any other resources that we may need for that part. All right, so let me know if you can see or download the file, or if we may need to send it in any other way. All right. Okay. Now let me share my screen here. And let me stop this part. There we go. All right. Now let's see. Let me open up these slides. Did I close them? I thought I had them open. One sec. So we have quite a lot of people during this week. I would like to see if there's many. We have people from all over the place. We have different time zones. Hopefully, I'm not making you guys work after hours or staying late at night. But thank you for being here again. I see quite a lot of people during this session, so I really appreciate it, Tim. All right, let's start here. Now, once again, welcome to our CIA bootcamp. During this week, our goal is to extend your technical knowledge in a instructor-led session that's within the support organizations, right? Now, initially, this was delivered by, I think it was just multiple persons, and now we're doing it just so one person can stay with you during the whole week and address maybe any follow-up questions that may not arise in the first day. Now, for this week's agenda on our first day are going to be first talking a little bit about what Zscaler is, some of its core concepts and functions, and what's maybe some of the difference between some of them, right? During this also, or during the second part of our session, we're going to have an architecture overview. Well, we'll see what happens when we're connecting to the cloud, what exactly are we talking to, and how Zscaler manages to load balance all of the traffic that's receiving from such a large amount of customers, right? During the next section, we'll start then talking about traffic forwarding. What will be a GRE communication, pack file, IPsec, and client connector. It's very important that we either practice or see most of these traffic forwarding scenarios that we will be doing it during the class, so we can understand what will be impacting, because some of these traffic forwarding mechanisms will be changing or won't behave in the same way as the other. For example, some of them will be intercepting ports 80 and 443, while the other one is intercepting only HTTP and HTTPS, which usually overlaps, but there are going to be some corner scenarios or different applications that work differently. On day 3, we're going to be talking about the user authentication and all the different type of communications that Zscaler can do for these user type of authentications. We'll talk about all of them, but I usually focus on the SAML authentication and also the cookie-based authentication, which is used with the browsers instead of the client connector. So we'll see the difference between them, how we can address the situations when we're dealing with user authentication problems, and what kind of details we need to look for as well. We're then going to get into virtual machines, where we'll talk about just some of the VMs, what they do, what they're intended for, and we're going to be deploying a couple of them. I will be giving you a demo for a virtual service edge, and we'll be talking a little bit about that. And also, you will be deploying a NSS server to stream the logs into a syslog server that will be running on the Ubuntu machine of your SkyTab environments. On day 4, we'll be then jumping now into the admin portal, which, as you notice, it takes us almost 3 days to get to the admin portal. And the reason why it's because it's very important to get that baseline understood and clear before we even start talking about policy enforcement. because there won't be any policy enforcement if I'm not understanding how the traffic is reaching into the cloud and how I'm registering or seeing the user information. So by day 4, we're going to start now talking about the mobile portal, how the threat prevention and policy enforcement works, and the importance of the SSL inspection within all of these communications. Then by day 5, the idea is that we have most of the deployment performed or created, and you guys will be either expanding on some further exercises that you may want to try, or troubleshooting any issues that you're having during the deployment, because sometimes we may have issues while doing one exercise or another, and you may just take it on this day 5 so you can finish up things if necessary. I'm also going to give you some baselines about best practices and some of the most common scenarios and issues and how to approach those troubleshooting problems. The good thing is that by this day, because we have been deploying our scenarios or our environments for 4 days, by day 5, most of those issues, you would have seen them at some level or another. Either you or some of your or some of the other persons on the class will have experienced it and would have seen it at least once, or at least that's the overall intention and experience during these classes. All right. So that's our agenda for the week. Once again, we're going to start with some initial introductions about what Zscaler is and some of its core functions. So, as we know, Zscaler it's a web gateway for outbound internet traffic, and we usually are going to be seeing that, or we'll see that in the form of a service called Zscaler Internet Access. With this service, the customers will be connecting to a endpoint or a data center. That data center is also known as a public service edge. That service edge will be basically a place where the customers for Zscaler will be connecting to, either with a pack file, with a GRE tunnel, with an IPsec. All of them will be able to connect to a data center, regardless of the type of traffic that they have. If this is a corporate connection with a GRE tunnel or an IPsec, all of them will be able to connect to this Zscaler service in order to protect the internet-bound traffic. So our intention is to send mostly HTTP, HTTPS, AD, 443, but we can also send all ports and protocols of the traffic that's going to the internet and provide them with further actions like IPS for non-web traffic, the cloud firewall, overall communications, and things like DNS. With CPA or Zscaler Private Access, we are expanding this type of services, or basically giving them a twist with the protections for the private communications or the private applications that the customers may have. So what we're doing is that we are going to be providing an alternative to a traditional VPN by creating mutual certificate PNTLS tunnels. Those tunnels will allow the traffic to traverse over the internet and connect to the applications via a microtunnel. So we'll be seeing just a couple of examples of the difference between those two. Also, we have another service called Zscaler Digital Experience, which is a very powerful monitoring tool. With CDX, you can probe different applications to or from different locations and clients. You can also gather very specific information from the clients, like their CPU usage, input and output information from their memory, and even their Wi-Fi strength signals and things like their battery level. So CDX can provide a very robust and comprehensive overview of the performance from either a client specifically, a whole region, or towards a specific applications. And finally, we have the Zscaler's cloud protection, which is usually the last part of that transformation within the Zscaler journey. Now we're talking about workload segmentations, cloud connectors to protect traffic like IoT devices and some of these other kind of connections, and the security posture management that expands on the protections for the endpoints themselves. Now, if I want to look or dig deeper into any of these details, do anyone knows if there is maybe a place or a document from Zscaler that may provide me with some of this? Any idea? Right, no worries. Feel free to use the chat also if you want to respond to the questions or if you want to do any kind of interactions. Also, feel free to unmute yourselves at any time. We can make this as interactive as you guys want, right? So don't be shy. Don't feel free to ask around. And anyway, I'll be also calling out specific people to ask questions during the whole week as well. So or where can we find all of these details and much more in the help.zscaler.com portal? This is going to be our main reference or our first reference for mostly any kind of research that we are doing. We have documentation for basically all the services. Sometimes when it's very new, then we may have some differences there or some maybe not the ones that are not as much information as we want. But again, that may be just because it's something that's very, very new. Now, as you're seeing here, we have CIA, CPA, CDX, and posture control. So the exact same four that we were seeing on the slides are represented here, and you can dig deeper into all of this. We can see a getting started guide, what is the architecture, the configuration step by step, the admin portal overview, and then the more detailed communications about the reference architecture and how things may be working at some point or another, right? So once again, this is a very good place to start and to get familiar with also some of the concepts that we're going to be seeing during this whole week, right? Have you guys seen or used this at some level before? This documentation?
Yes.
Awesome. All right, all right.
Yes.
Excellent, team. So, let me see. Now we're going to start talking a little bit about the CIA architecture, right? So we're first going to be talking about the architecture, and then we're going to start talking about traffic forwarding, right? So we're first going to be basically get to know the cloud, what is in each data center, what type of nodes might not be present into every data center either, right? So let's take a look. Now, our objective is that by the end of this module, you guys will be able to describe and explain the role and responsibilities of different type of components like the SMCAs, the SMEs, the different type of load balancing mechanisms used by the load balancers, and the use of some of the other non-production clouds like the Feed Central Cloud, where we get things like the reputation checks and also the sandbox infrastructure as well. Now, the first component that we're going to be seeing or that we're going to be talking about, it's the central authority. The central authority, it's a component in the cloud that it's holding the entire database for that specific or for all the organizations for that matter. it's always, or it's the master node that it's also checking in the performance of all the other components. So if a particular data center or virtual IP it's unhealthy or it's having a performance problem, the central authority is the one in charge, or it's the one in charge of making sure that no further traffic is redirected to that virtual IP, or at least not intentionally from ourselves, in order to avoid having more problems or to keep getting disconnections or to create performance problems from the customers. So the central authority, it's the brain of the cloud where we have very sensitive information and all the policies and configurations for the customers. One other, one second, team, I just got my headphones disconnected. Give me just 1 second. Sorry about that. All right, can you hear me, guys?
Yep.
I think I'm the one not hearing you. Give me just a sec. One moment, team. I'm sorry. One second. It seems like my headphones are give me a problem here. You know?
Yeah, can you hear us?
Yeah, I can hear you. All right. All right. Okay, that's good. Yeah, no, it's just that the microphone is separate from the headphones, but I basically end up not hearing you guys. So yeah, sorry. Okay, cool. Now, the central authority, it's also in charge of the user authentication. So sometimes that user authentication needs to be also relied on to a third party like a identity provider, right? So that communication during the authentication, it's also against the central authority. So what are the key things that we need to keep in mind about the central authority? Is that it holds the entire database, is in charge of monitor all the components in the cloud, and it's also the one in charge of the user authentication. Make sense? Any questions? Not sure if it's no
Yeah,
questions
makes
or I
sense.
lost. All right, cool.
Yep, we're good.
All right, all right. So then we have the SMUI, or the user interface, also known as the policy portal. With just a quick question here. You guys know why is there an SM in front of mostly everything?
Is it single scan multi-action?
Nope. Actually, it's because of a very old name that Zscaler had. It's the first name that we had. At least that's what I heard of, or what I've seen before. It stands for Safe March. It was basically it stands for Safe March Central Authority, Safe March User Interface, Safe March Enforcement Node in the case of the SME, or Safe March Enforcer was it, I think. So yeah, just a little bit of a little thing to know about. It stands for Safe March, which was one of the very first names that Zscaler architecture had at some point. All right, it seems like I had the question, yeah, right there with Praveen, yeah. So yeah, it's basically Safe March. All right. Now, the other component that we're talking here is the UI, which is basically where we create everything, right? We're gonna be accessing the UI when we get into, for example, admin.zscaler3.net, right? So I am accessing a UI server that is on the Zscaler's cloud. This server or this component in the architecture, it's where the admins will be interacting with the configuration. But eventually, we're going to be sending this configuration to the SMCA because that's where all the sensitive information is, right? Anyone knows how do we send the information from the UI to the SMCA? Have you seen it?
Maybe an API?
Yeah, but mainly if you see where on the UI, if there's maybe something in the UI that's telling you to push that configuration on the CA, even after you save it. Have you seen it on the UI before?
Oh, the activate button.
Right. Yeah, there you go. There you go. Yeah, right. The activate button is the one, right? Every time that we're doing activate for any changes, for example, just for testing here, let me just get this SSL bypass and let's do maybe let's remove Netflix from here, for example. And we're gonna be saving that. And even after I save the configuration, this is not pushed yet on the SMCA until I hit this activate button, right? That's basically what that's all about. Have a question here. Is the CA part of CIA or is it separate level to manage everything? It is part of the cloud, but is not in every single data center, right? So for example, we only have, let's say, 3 central authorities working as a cluster with one master, and they're distributed in all the Americas, for example, right? But just one master, and it may just live in one DC. Make sense? Awesome.
Did I hear that right? The central authority, there's only 3 of them, and it's not
No, it was
distributed
just an
like the other?
example. That was an
Oh,
example.
okay.
There are more, but yeah, that was just as an example to kind of like put it into a scenario where you're managing just a whole region. For example, Americas, right?
Okay. Sorry, I completely misunderstood.
No worries, no worries. That's good. Okay. So until we hit that activation, the SMUI is not gonna be, or the central authority is not reflecting those changes. Now, then we have the component known as the SEN. Also, sometimes it's called, or nowadays, it actually has a different name, which is Service Edge, right? It can be public or private, but a Service Edge is basically a SEN. It's also considered a data center, right? So if we need to find or know what are or where are all the service edges and what virtual IPs I can connect to them, is there maybe a place where I can find this information, or should I always contact support to know where do I need to connect? Let me ask someone here. Oh, yeah, Praveen got it there. All right. Yep, the config page. config.cscaler.com. It's a website where we can check and verify all the different IPs of the components for a specific service edge. For example, in this scenario, we're looking at cscaler.net, right? And we're looking at the cloud informant node ranges. We can see here that we have, for example, the service edge in Amsterdam will have all of these IP subnet ranges. And we can connect to that service edge depending on our traffic forwarding mechanism as either a PAC file or a explicit proxy by just putting this hostname on our proxy settings or on our PAC file configuration. We can also connect to this Amsterdam service edge using a GRE tunnel. And that we're seeing here, it's a GRE virtual IP. Now, as you notice here, for example, we have 2 virtual IPs for Amsterdam and these tunnels, right? One is for, it seems like a older uh, or the first cluster that was created maybe at some point, right? But as you see here, we have Amsterdam 2 data center. We have two different virtual IPs. Same thing for SVPN virtual IP. So this is pack file or proxy, right? This is GRE, this is VPN and SVPN. What's the difference between those two? Any idea? Let me ask someone here. Maybe Tucker, how are you today, sir? Let me see. Maybe you're double muted. Tucker, can you hear me? Maybe I cannot hear you.
Sorry, what's the question?
All right, there you go. Hey, how are you?
Okay, how are you?
Doing good, doing good. Thank you. So, just a quick question here about these nodes that we're seeing here. Do we recall or know maybe what's the difference between these two? What's VPN hostname versus SVPN, and what is this all about? Any idea?
I don't work with Zscaler enough to know, but I'm assuming it's like the backup IP, I guess. I really don't know.
All right, no worries, no worries. That's fine. So this is well, these are all virtual IP addresses, right? So all of this is going to be resolving to either one or multiple virtual IPs, as same as these ones, right? Now, all of these virtual IP addresses are active. I can connect to any of those VIPs, regardless of the the status. For example, I can directly connect to one or the other. They're all active, right? So they're all managing customer connections at the moment. The main difference here is that this one right here is intended for tunnel 2.0 with Zscaler client connector, because that is an SSL VPN tunnel. That's why it's showing SVPN. Now, we also have this one, but this one is for IPsec tunnels. So we can either use the host or resolved to this host to an IP address, and that's basically a virtual IP that we can use to make a IPsec tunnel against. Make sense, Tim?
Yeah.
All right. Now, are both SVPN always active? Yes, all of those are active on unless they told you here that this is not yet in production, right? But everything that we see in this page are virtual IP addresses that are mainly active. Usually, depending on the specific data center, you may only have one specific VIP. But if the data center sees a lot of traffic, like in this case, it could have been that they eventually, or they might have just came up with this one first, but as there were more and more traffic going to Amsterdam, they needed to have more components or more nodes, and they had to basically create another BIP. Or they're having a newer version of software, and that's why we're having a separate BIP for the same type of communications, right? So usually that's going to be the reasons why you'll see multiple BIPs, but they're always, if we see them here, they're going to be active. Now, an example here. I'm connected right now with my corporate connection to Zscaler. And if you notice here, this is my client connector. I'm going to tunnel 2.0. That's my tunnel version, right? And there's a server IP here for my connection user using internet security. So if I just go ahead and check this, also I need to know which cloud I'm in. So I'm just going to go ahead and check that in here. So I'm connected to a data center in Miami 3 to a cloud Zscaler 2.net. So far, so good, right? Okay, now, if you notice one thing here, let me move it here to this other cloud, scalar 2. I'm gonna look at the data center in Miami. Here is Miami 3. And if you notice here, under SVPN, I have this as the virtual IP address, right? And let's take a look at the client connector again. It is the same IP, right? So again, you can use that config page to find all the virtual IP addresses that these nodes and service edges have. But overall, what we're seeing here is the service edge of New York, the service edge of Montreal, the service edge of Miami, and all the virtual IPs depending on the traffic forwarding mechanism. And these ranges here tells me that even though I'm connected to 165, 225, 222, when the traffic is received by the application, that's going to be processed by an SME. And that application may be seen with the range of 136 to 26. We're going to be talking about why. That's when we're talking about multi-clusters and things like that for load balancing. But that's just basically what this page is telling you, right? You might be sending traffic to destination 165 on your tunnel, but the website on the end here might eventually see the traffic coming with a completely different source IP, just because we have different ranges and lots of other nodes. Make sense?
So are you able to lock down that you're going to Miami, or you might not would even want to do that?
You can do it theoretically, or even just manually configure certain things, but we may want to. We always want to try to make or let it do as automatic as possible. So spread the traffic as much as we can, right? Because if you only point it to one single node or to one endpoint or things like that, you might end up having performance issues or a point where load balancing is basically not taking effect, right?
Yeah.
Um, there are other scenarios or solutions. For example, if you need to preserve a specific IP from these applications, then there are other options that we usually provide with. Eventually, again, you can do it something very manual, but it might not be the most recommended way to do it.
So I noticed there's a little legend here that says regional surcharge.
Mhm.
Is can you explain that?
Absolutely. Yeah, that's a great point. These are basically data centers that you need to pay an extra fee to use. Because of it's maybe more complex to manage the traffic in those areas, or it involves additional charges because again, it's maybe heavier to manipulate the traffic there too. Usually, one of the most common examples, it's the data centers or the China traffic. That's one thing that's basically its whole thing. But that's things like where we have these kind of regional surcharge nodes. So yeah, basically nodes that we need to have an extra or pay an extra fee to use because they need some special either permissions, restrictions, or maintenance. Now,
Okay,
one
so we're
interesting thing about these nodes is that it's not like they're gonna be kicking you out if you use them. My point is that, for example, if I just point the traffic to any of these proxies, the traffic will work, right? It's not like you're gonna have to do anything different in regards to user authentication or anything like that. So Eventually, you might need to use one of those nodes, but maybe just for a shorter period of time. For example, just to give you an example of that part with one of my customers at some point, they told they were only on the Americas. They all their business and everything was only on the Americas. But they had an executive that was traveling, I think, to China or somewhere nearby there, and they needed to use some regional surcharge notes, but it was just for that executive for about a month. So all we did is that we talk it out with sales. They told them, "Hey, no problem," and we just go ahead and configure the pack files. But there was no a special configuration involved at some point, right? Of course, if we see traffic trending over a specific client to one of those data centers, we're definitely going to start engaging into those conversations. But my point is that for one-off kind of things, it's always negotiable.
Okay, so
So
it's not
from
like
oh, go
uh
ahead,
it,
go ahead.
it's not like I I just configure my pack file that lets me use the node and you charge me a rate. Like you actually are gonna uh have a discussion with the customer and say, okay, if we noticed you're using this node, if you want to start using this node, we need to change your monthly cost, basically.
Yeah, or basically add that SKU to the bundle or something like that. Yeah.
Okay.
And then during normal conditions, if I know there's some defaults in the pack file, does that mean while traveling they will still connect to the nodes that connect to the more restricted nodes automatically, or would they still connect to the nearest node that's not bound to any special circumstance or condition?
Great question. Yeah, actually, it doesn't work with those defaults. That's part of the whole thing, right? Because yeah, we you need to basically point the traffic there, and we don't want everyone to just get there by default, right? Because that's where the whole restriction is for. So yeah, things like the gateway variable or country gateway variables that we use on the pack files to get to the closest DC, they not taking these regional surcharge nodes into that rotation.
Okay, thank you.
Cool. All right. Excellent. Thank you. Thank you so much, guys. So these enforcement nodes will have quite a few nodes also inside of those. We'll be zooming in to the cloud a little bit more, and we'll be talking a little bit in these next few sections there. We also have a node called the cloud router or the relay router. The main purpose of the SEN is to manage the end user's traffic. So we want to take off as much process unnecessary as possible. So things like finding the streaming or the analog servers could eventually present a performance compromise for the SEN. And that's why we move that to the cloud router. The cloud router, it's in between these service edges and where we store the logs for the customers. That's known as the Nanolog clusters or SMSM servers as well. So these cloud routers are basically the ones that redirecting where the logs are going to be stored for the clients. Anyone knows for how long do we store the logs for the Zscaler customers?
2 weeks.
That's in the case of CPA,
Okay.
but for CIA, it's a little more.
6 months.
60 days.
6
I thought it was
months.
90 days.
It's actually it's 6 months for CIA traffic. 90 days, I think it's the user removal time frame. But yeah, we have 60 day, I'm sorry, 6 months where we're gonna be keeping the customer logs. After that, they're removed. That's why sometimes or most of the time the customers may want to still send some logs to a SIEM solution or syslog server, right? Then we have a simple mail server that's for sending DLP violation emails and alerts to the administrators. Now, the Nanolog servers that we were talking about before, where these servers are used to store the transactions that are received from the service edges, and it writes the data into a compressed ID form. Then we have a pack server. The pack servers are where the pack files are hosted. These pack servers can be sent over HTTP or HTTPS, and these are also going to be in charge of following some of those dynamic redirections that were discussed on these initial conversations. So things like the when a client wants to talk to a specific DC, then they're going to be first downloading the pack file from these pack servers so they can connect to those service edges. Now that we've seen a little bit of those nodes, let's take a look at this image. We may come back to this image from time to time, just to make sure that we're having clear the overall concept of these components here, okay? So the first that I'd like you to notice here, it's the service edge. So, or also the SEN, right? That's basically the one that is all over the cloud. So they are gonna be basically delivering the perimeter for this specific cloud. That's gonna be for each of the clouds. So this is, for example, all the cloud for Zscaler 2, right? And this is the data center in Washington. This is the data center in China. And this is the data center in, I don't know, Colombia, for example. And this is the one in, I don't know, Germany. So all of this will have virtual IP addresses. All of them will have nodes that will need to forward the traffic, right? Now, we need to connect to any of those via any of the traffic forwarding mechanisms, GRE tunneling, pack files, explicit proxy, IPsec, so on and so forth, right? In this case, let's say that we have a IPsec tunnel and we're sending the traffic to this service edge. So if this is a location type of connection, we may not need to request a challenge for authentication, or we may have the authentication enforcement enabled or not. Basically, the SEN will basically check for information like a cookie or a digest ID information from the end user, so it can actually correlate it with some organizations or users. If this SEN does not have that information, the first thing that we'll do is redirect the user to the central authority for user authentication. Once the user authentication is complete, the SMCA will redirect the user back to the service edge with now either a cookie or a digest credentials, also known as device ID and ping. This is when we're using the client connector. We're going to be expanding on this part, but basically that's what the SEN will be looking for. The SEN will receive the traffic or will be now authenticating the user. Now, does that mean that it will now talk to the internet, or there's something else needed before? Let me see, Survey, what do you think? We have a user connecting to the cloud. It's authenticated. Now what happens?
I, if it's authenticated, I think it will connect.
All right. Anyone else agrees,
I don't think it
disagrees?
ever goes directly to the internet. I think it always goes through Zscaler.
Yeah, it will check the policy. Uh,
All right. Yeah, policy enforcement will be the next step in that part, right? So
Yeah.
once the user is authenticated, I know who it is. I now have criteria that I can use on my policy enforcement, right? So that criteria will let me know if I need to do things like SSL inspection, if I need to do URL filtering, cloud application control, DLP, sandboxing, and much more different things, right? And also depending on where is this traffic going. In this case, this is basically a GET request to a web server, right? So we are doing all of that based on this outbound connection. Now, who is telling the SEN what policies it needs to enforce? What do you think, Jason? Where is the SEN getting all this information? Let's see. I have Samira telling me SAML. Some of that information will be from SAML or from the SAML assertion. That's correct. But there we go. Also, yeah, there you go, Praveen and Miho, yeah, will be the SMCA, the one sharing that information. Because remember, we did all of that on the admin UI, right? And the admin UI pushed that information on the SMCA, correct? Make sense? So far, so good, team?
Yep, makes sense.
Yes.
Awesome. All right. Now, what happens if the user is connected here and I make a change on the UI and push it on the SMCA? Will that change be reflected automatically or maybe it takes a few minutes? What do you guys think?
It should take effect within 30 seconds or so.
Takes a few minutes, maybe 15 minutes to 1 hour. Or if you want to replicate, we can update the Zscaler client connector to get the latest configuration.
All right, one thing there, because that's actually two separate things, right? Here we're talking about the policy enforcement on the SEN, right? In that case, it's a change that may be on the client itself. When we need to update the policy for the client connector, that's the one that may take a little bit longer, right? And that's the one that we can push with the option available on the client connector, like this one over here, right? Update policy, right? But in this case, it's a SSL URL filtering policy, something that's enforced on the SEN. So what happened here is that when this user was initially connecting to the SEN, if this was a remote user, or if this is a location, the SMCA knows that the traffic for Davis's cloud, for example, it's passing through this SEN. So if the admin makes a change on the SMCA, I know that I need to push that into the SEN because there is traffic going through that SEN that needs to have now a different action. But basically the SMCA keeps track of all the nodes that they are, or basically all the SMEs and their connections and their current status, right? Okay, so now that we enforce the policies, we are telling or basically deciding if this traffic will need to be allowed or not, right? So based on that information that we now have, we need to, let's say, we need to block this transaction if it's going to a malicious website. And that's what the policy is saying from the SMCA, right? But now we have another situation here. How does the thing know what is a malicious website, right? Any idea?
I mean, it's got all those third-party integrations, so it's already got a database.
There you go, right? It has a database for all of that. either based on reputations or URL informations, but it's basically going to be getting some database information. And that database needs to be updated, right? And needs to be constantly updated, actually. So for that, we have a third cloud that will be also interacting with all of these nodes. That's known as the Feed Central Cloud, or FCC. That cloud, it's, as you see here, connected to other SANs and also the SMCA, so it can provide constant updates about all of those third-party feeds, so this thing knows if something is malicious or not based on what. Okay? So far, so good? All right, I'll take the silence hopefully as a yes. All right, let's keep on going here. Now that we have basically enforced the policies, we have the data to enforce those policies, we are now from the SME connecting to the application on behalf of the end user, right? So what IP will the internet see? We'll see the public IP of these SMEs service interface. Okay? Now they will be sending me back a response, and that response, let's say that that response was an executable file, right? And although it doesn't tell me that it's malicious, I may still not know if this traffic could potentially be malicious or not. So for that, we have the behavior analysis environment, or SMBA, which is basically where we detonate the files into a sandbox environment. We also have other services like the isolation. In that service, what we'll do is that instead of sending the actual response back from the server, we are rendering a specific connection and sending that to the client. But the BA, or behavior analysis environment or node, it's where it will be taking those changes there. Now, how long it takes for the configuration changes on the SMUI to reflect? You mean for them to reflect on the SME? Almost immediate. Depending um, on the feature, because I've seen, for example, with SIPA, that either I'm maybe I'm still doing something wrong there, but I've seen maybe some delays with things like that. But if I make a change on a URL policy or any of those kind of things where I need to block something, it should be reflected right away. The only thing that may not show us the block page right away, it's if the browser is caching the response. And therefore, you're basically not seeing the response back all the time. They're just giving you what they kept in cache. All right. Now we can detonate the file on the behavior analysis node, and then either send it back to the client if it's not malicious, and so on. All of these generated some logs, either allowed or blocked. This has generated some events that tell us what did the send do with this traffic. So this is sent to the cloud log router, which then sends it to the respective nanolog clusters. We have different regions and clusters, for example, for this. So usually one single client, it's into a single cluster, but depending on the size of the customer and how expanded are they worldwide, we may have them in multiple clusters. Now, we haven't talked about the DNS resolvers and the back servers here yet. Those are additional parts of this, as you see, SMCA environment, or part of this whole infrastructure, which is the first connection that we may have to download the destination of the service edge. as well as to resolve any kind of DNS traffic that we might be sending to the send. They might be connecting to those DNS resolvers or forwarded to those resolvers as well. Any questions so far here, Tim? With the overall overview of the clouds?
Good to know.
All right. How you feel with this one? Is it too complex? Is it okay? Was it digestible?
It's okay. I think just diving into how you have to exclude DNS when you're setting up the policies on almost every single policy. Why why does that happen? Why can't Zscaler just know that automatically as part of its own infrastructure?
You mean their DNS resolutions that they're doing? Because actually I do use Zscaler's resolvers from time to time, just in my configuration like that, without an internal DNS server, or even just point it out to the internet as well.
No, I mean
But not,
when you're configuring, I think it's a policy. I don't remember off the top of my head, but I think it's a policy, and you go in and you can specify the ports in that policy, but you have to exclude DNS. It even tells you should exclude DNS on there. So now you have to create like 4 lines just to exclude DNS when I feel like it should be built into the architecture.
Okay, not really sure about what is that use case, but we can definitely explore that a little more. Uh, because I've seen those kind of things maybe when we're dealing with very specific configurations like SIPA. In SIPA, we need to configure DNS control rules. So instead of exempting that, we actually need it to be on the cloud. But yeah, we'll maybe expand on that one a little more once we get a little deeper into the client connector forwarding modes. Okay.
Okay.
Cool. Okay. Now we're gonna be just talking a little bit more, or giving a quick overview of these components before we jump into the traffic forwarding part and we start digging a little deeper there. Today's session, it's a little bit more of a lecture because we don't have, or we were gonna be basically creating the environments for you guys, and not much of hands-on during this first day. So I apologize for that, team. But hopefully now by tomorrow we're gonna start getting into some of this. Doesn't mean that we're not gonna be doing exercises, but maybe just not a hands-on task for now. Now, before we keep going into all of this part, would you guys like to have a quick break before we continue with our call? Usually I like to give about 25 minute breaks right around the hour and a half mark. So we can always have about an hour and something for each of the part of the lectures. Will that be okay, guys?
Yeah, sounds good.
Sounds good to me.
All right. So I'm gonna put the timer on the screen, and when we're back, we'll just continue digging a little deeper into the architecture, and then we'll jump into traffic forwarding. Thank you all. Have a good one, and I'll see you soon. All right, team, we are back from our first break. Now, on the React options of Zoom, you should see an option that says raise hand. So please raise your hand and we can check on the attendance before we get back into a call. Remember that it's very important that we stay or that we are on the call for at least 80% of the session, hopefully all of it. so we can get all the information, right? It's not always the same thing to see the recording. All right, I see like 8 people, 9. You may use the chat as well. Okay, let me see. I have a few people there missing. Sakshi, Bermuda, Gino is there. Cash. No worries. Yeah, again, if you don't see the button or if you don't have it there, just use the chat to let me know you're back. That's fine too. All right, all right. Thank you all for being back on time, and we're now gonna get back into our call. Now, we've been talking about the architecture and basically how all of these components interact with each other. It's important to understand that, at least just to maybe get a sense of where things might be failing. For example, if I'm making a change in the configuration and I don't see the changes when I'm doing the enforcement or when I'm doing the traffic forwarding or when I'm forwarding traffic, um, then I might see that there might be a problem either from the SMUI sending it to the CA or from the CA to the SME, which at that point we may need to rely on the support team or internal support team for more debug information on on these particular nodes. But again, just maybe capturing that the events are not happening based on the configuration might be sufficient to start on that conversation. Now, just to recap in some of these components that we were talking about, the SMCA, it's the most critical part of this puzzle. It stores the database, takes care of the user authentication and provisioning, monitors all the nodes, and keeps an up-to-date view of the entire clouds. The user's company and config management, it's done by this SMCA. They keep a global database that it's basically maintained within a whole cluster environment. When the user sends the traffic to the SME, it identifies the location, downloads all of that from the SMCA. The SMCA and the SME will have 2 connections. One primary channel that is used to send all of these sensitive information like health messages and the configurations. And the secondary channel, well, will maintain more static tables like the map for the IP information in the IP surrogacy and the time quota for any kind of bandwidth usage or time to use for specific applications. Once a request gets on the SMCA, that SMCA, as we were saying before, keeps tracks of the SMEs having the company's configuration downloaded. So when that admin make the changes, those will be immediately changed or should be reflected on the end user's experience. Let's take a look at that real quick. We might be able to do a quick demo for that action. Right now, I have a user, I think on Zscaler 2 or Zscaler 3. So let me see which one is it. So we'll play with that one a little bit here. So I have a user here from Zscaler 2. And I'm making a SSL VPN tunnel. And this is the virtual IP that my user is connecting to, right? Now, if we go to, let's say, maybe bot SSL could be an option. We go to bot SSL and we try to go to an untrusted root certificate. We get this security threat and this access denied because of a bot certificate, right? Now let's make a change in that admin portal to see if we can pass through that traffic and see if that it's immediately changed on the user experience. Okay, I've had the SSL inspection policies. This is to inspect suspicious categories. I'm gonna disable most of these for now, just to make sure that my traffic will be hitting the right policy, or maybe I'll just move it up. Now, in this particular policy, I am blocking the untrusted server certificate. So I'm just going to change that to allow. I'm going to change this to rule number 1 just to make sure that it gets hit. And I'm going to try it again from that client. Now, again, I'm pushing the activate button on the SMUI. So if we go back to this particular graph, I'm currently making the changes here. And once I push the activation, it will be sending that to the SMCA. I currently have a user connected to that send, which is connected over tunnel 2.0, right? So now with those changes in place, let's see if we get, did I get the right one? No. Let's activate the change. And I try to go to the untrust cert. It seems like it's still getting that one. Maybe it's cached. So I'm just going to be trying it out again. And we go to the untrusted root and we can go through. So you see that it's basically just immediate. The only thing it was maybe just the browser having that cached. But other than that, the experience is basically immediate from the end user. Any questions? All right, guess not. All right, team. So let me make this a little smaller. For the user authentication part, the SMCA, it's the one taking care of the authentication and the provisioning. We support a bunch of different mechanisms for provisioning, but let's talk a little bit about what is provisioning and what is authentication, right? So anyone might want to help me out explaining or tell me what's the difference between those two?
Authentication is going to involve credentials, and provisioning is going to be getting the, I guess, the laptop set up with, whatever it might need, like the
Okay, well,
client
but
and such.
okay, but in the terms of Zscaler, what will be provisioning for Zscaler? Provisioning a user.
Oh, I mean, it's probably going to be SAML. It's going to be,
Yeah, SAML is involved. We can either use SAML AP or SCIM. But if you need to tell what is provisioning for Zscaler, what do you think maybe is what action is, or what is it used for?
I guess I'm not understanding the question.
Okay, let me maybe take this this way. When we're connecting to the Zscaler service, right? And I'm talking to that central authority, I'm telling them, hey, I'm Davis, right? But where do they check where is Davis or things like that, right? So provisioning, it's giving the central authority a database that tell, hey, for this specific cloud, I have a user named Davis, right? And now that user is provisioned there. Authentication will be the act of checking the credentials of that user, right? With either SAML or LDAP or any other mechanism. But that's why both of the actions are separate. One, it's, hey, I'm going to be creating my database, or I can maybe prompt or look into an LDAP database, which in that case, I need to have access to that database at some level to get some queries, right?
Oh, that actually makes a ton of sense.
All right, nice. Cool. Now, provisioning, it's any of those, right? We have the option to provision our users with any of these mechanisms. Mainly, we're going to be dealing with a combination of this with this, because we're going to be filling out this hosted database with the SAML and scheme provisioning mechanisms. We're going to be talking much more about this. I don't want to deviate the conversation to authentication, but we'll be basically using these mechanisms to fill out this database with the user so we can then later also do the authentication. Now, the authentication part, it's validating those credentials. So that can be within that database, or I can trust a SAML response as well as validate any kind of Kerberos tickets, and also check that against an LDAP server if I'm not wrong, but that's at the end of the day, I think some sort of local database as well, but it's basically binding the request against the AD server, yeah. So the SMCA takes care of doing all of that. Within this week, we're going to be checking of how to identify when it's doing one or the other, either by checking configuration on the admin portal or by doing or checking some information on the header traces while the user is authenticating. Now, as you know, it monitors all the nodes. We do that by creating two types of health monitoring. One is the passive health monitoring, and the other one is the active. The passive means that all the nodes will be sending their updates to the SMCA every second. And if that primary health check fails, then the SMCA will create an inbound connection to that node and trigger some health check connections or some connection attempts. If those fails, then the alarms will be raised by the SMCA and the node will be removed from rotation. All of these nodes are managed by a master SMCA. As we were talking about, they're not all over the cloud or in every single data center. Let's say about a cluster of 5 or more, or about 5 nodes. It's what we're talking about. All of these nodes are keeping a copy of the database, but only the master has the permissions to write into this database. So when the SMUI is pushing changes, only the master can write those changes on the database and then replicates that into each of the other SMCAs. Very similar to a OSPF designated router type of thing. The system ID with the lowest ID wins or gets the master. Not something that you will need to manage or see, but just something to notice from there. All right. Now we're going to be zooming into the service edge a little more. And we're going to be talking about the components that are part of this architecture, like the SMLB, SVPNs, CVPNs, and SMEs. This is now when we're basically connecting to those service edges, and how are all of those connections managed? We're talking about millions of transactions every single second. So it's a lot of traffic that needs to be load balanced and managed in different ways, because we're talking about multiple tunnels as well. So all of that needs to have some specifics. So the nodes that we'll be talking about are the SME, ZVPN, SVPNs, and SMLB. These are nodes that will be managing a virtual IP address. The virtual IP address is a shared IP in many instances. It could be between an SMLB and SME. It could be between an SMLB and an SVPN, or it could be between a SMLB and a ZVPN, depending on the traffic forwarding method. So we're first going to be hitting the load balancer, which is basically where we start load balancing the traffic. And we decide if that traffic needs to go to an SVPN, CVPN, or SME, depending on the destination virtual IP that it's configured, and that needs to go in line with the traffic forwarding mechanism that they're using. So far, so good. Any questions? All right. Now, one thing to notice, and this will becoming more relevant when we're talking about the virtual service edge, is that the Zscaler nodes are running the Zscaler operating system. This uses two service and management IPs and interfaces. The service IP and the service interface is the one that it's used by the Zscaler OS, and it's where the traffic of the clients is passing through. The management IP and the management interface are used to communicate with the cloud as well as to also connect with the nodes via SSH. These service interfaces are using our own TCP/IP stack, which is called SMNet. Once again, SM standing for Safe March, right? I think, if I'm not wrong. So the first node that we're going to be talking about is the SME. This is where the policies are being enforced. The traffic that we're sending, regardless of the traffic forwarding methods, will always end up going out to the internet from an SME. So we can have multiple clusters of SMEs, and they're all going to be receiving traffic from multiple virtual IP addresses or from all the different traffic forwarding mechanisms. Here we have a quick overview of how these kind of nodes are seen in a logical perspective, where we have the load balancer that once again is active for, let's say, a specific virtual IP for a proxy, right? So the client is sending traffic to that proxy host name, and the load balancer will decide SME ID that will be handling that connection. Then if I receive another traffic from another client, that traffic will be load balanced and distributed to the second SME. Now, what do you think happens if I start having a lot of users all coming from the same egress IP? Is there any way I can load balance this, or will I still basically end up causing a performance issue on the SME?
You could use source and destination and load balance it that way.
Well, but in that case, it's always the same source and destination as well. Let's say that we have a NATed or a router here that's NATing all the traffic, right? That means that they'll only have one public IP, correct?
Sure.
And they have that over the proxy. So that it's going always to the same destination, which is the virtual IP. The SME will then do the resolution for the proxy connection and then connect with the app. That's the one that will talk with the actual. That's where the destination IP will change, right? But up until here, they're only sending traffic to one BIP.
You could do something with source ports. You could do something with user ID. I mean, there's a million different ways you could do it.
There you go. Yeah. That's where client connector will be playing a good part of that. The source port, as you were saying, it's used by IPsec, for example, when we're using like version 2. And in the case of PAC files, that's where multiple BIPs will come in handy, right? Because that way, if I have a second user that's sending traffic to that second BIP, Now I have now I have a different destination, and I can send it to the different SME. But we'll talk a little bit more about that once we get the traffic forwarding. All right, now the SME will be talking to the internet, and the SME is actually sending the traffic back to the client. Remember that I told you that the virtual IP is a shared IP between all of these nodes? That's because we're sending back the traffic directly from the SME. That's known as direct server return. But from the client perspective, all they're receiving back and forth, it's information from the virtual IP.
I had a question about direct server return.
Sure.
So in a typical direct server return, you would have to have something like a loopback that's bound to the interface and it knows where it's coming from. How does it work in this situation? Because there's multiple
Honestly,
devices in between.
I don't actually have that answer. I know we use I think I just forgot about the name of the protocol. Was it something like MTP or something like that? But I just or MST or MTS, something like that. I just forgot the name of the specific transport protocol that we use for these kind of things. But that's mainly ops. That's not something that I as support usually seen, because yeah, that's totally ops to the operations team.
Oh, okay. That's fine. That was more curiosity. I don't expect to ever run into issues.
Cool. Yeah, yeah. Neither do I, but yeah, it's something that we usually don't even let us see at that level, at least not for this part of the role. All right. Now we have also the ZVPN nodes. These are used to terminate IKE versions 1 and IKE version 2. These instances can be either breach or SMNet based. Nowadays, we have fully dedicated SMNet instances. I think there may be just a handful of them. And for your own perspective, it's not going to be something relevant. So we have SMNet based IPsec instances for the CVPN nodes. These CVPN nodes are going to be creating the security association. So it's only going to be establishing the security association against one single node. If that CVPN node fails, then the tunnel will need to be renegotiated, and we'll just reestablish the tunnel. Very similar to that or to that IPsec communication, we have the SVPN nodes. These are used to create the SSL VPN connections that once again are used by the client connector with Tunnel 2.0. Tunnel 2.0 allows us to intercept all ports and protocols. So we don't even need to have an IPsec or a GRE tunnel or PVRs intercepting the traffic there, which will become more important once we talk about traffic forwarding. And lastly, those SMLB nodes that are the ones in charge of load balancing the traffic. So these nodes are going to be sending traffic to either of these instances, sometimes even twice, depending on the traffic forwarding mechanism. And we, as we're talking about, use DSR to send the traffic back to the clients. We have either active passive, active active with single cluster, of active active with multi-cluster when we're talking about SMLB nodes, because we want to manage as many connections as necessary, right? So I have a bunch of power here because I have a lot of SMEs. But if I try to make sure that this is sending traffic to every single of those, maintaining all the connections that I could potentially receive on the cloud, it's very easy to overwhelm one single SMLB. So what we do for that is that we can have a whole cluster of SMLBs all actively working for the same virtual IP addresses. And for that, we use equal cost multipath to load balance the load balancers. Make sense? Now, that's in the case of active-active. In the case of active-passive, only one node is going to be the master. And if this node goes down, then one of the other standby nodes will become the new master. We're going to be deploying at least 2 load balancers in every single deployment, so we can have that redundancy accounted for. And with single or multiple clusters, it means, and we'll be taking a look at this one right here in just a moment. But basically, multiple clusters means that I could have multiple SME clusters. This could be one single cluster of SMEs, where I can have a different cluster of SMEs with a different range, remember? And that might be still be used by the load balancer that's in only one of the ranges. For this master backup, we use Common ARP redundancy protocol to get that virtual IP failover. And this is something that we're usually going to be seeing in those virtual and private service edge. And think very small data centers nowadays, but I don't think there are any more, at least in the public service edges. Now, this is a sample of how a SMLB cluster output looks like from a load balancer. This is telling us that the users are going to a virtual IP 161. As you may notice here, they're both sharing that same virtual IP address. One of them is master, the other one is backup for that virtual IP. The other 2 IP addresses that we see, 164 and 162, are the SMLB IP. That's the service IP of the SMLB. This other one, remember, it's a shared virtual IP, so it's not their actual IP. They need to communicate or have the information managed by those nodes. For example, the common ARP will be having the MAC address of one of the 2 IPs or one of the 2 interfaces here. We'll be exploring a little bit more of this once we get into virtual machines, and we'll be showing how to run this command, what is this command used for, and what other commands we can run that use the same kind of syntax. Now, as I was explaining before, right, we're going to be using equal cost multipath based on source and destination IP to decide this SMLB that will be advertising or used by the same given virtual IP address. In the case of multi-clusters with active-active, what we have is that we are going to be choosing, once again, multiple clusters that may be from different subnet ranges. That's why we might be talking to a virtual IP in the 104, 129 range, and the SMEs that are being handled on that communication can be on a completely different subnet. And these are the ways that the load balancers will be load balancing the traffic, either source IP and source port, source IP and destination IP, which is the default hashing algorithm, and other options depending on if we're using things like the client connector and other stuff. All right. Now that we have seen a little bit about what are all of these components doing, now the last part of this connection is the SME. The SME is where the policies are being enforced and where our traffic will be handled, and basically all the Zscaler services will be started from. This is achieved by a feature called single scan multi-action. This is a feature that allows us to basically execute the same packet or seeing it by multiple processors and allowing us to scan all these different services at once while we're doing that on memory. We're doing that for two different type of modules. We have the web and the firewall module. This is because we're either sending only web traffic to the cloud, or we are going to be making use of the cloud firewall capabilities for either web traffic or non-web traffic. That will depend on if we're sending, once again, traffic over these specific ports and protocols, and if we are sending that inbound or outbound. We only have outbound and outbound web traffic and outbound non-web traffic. This is traffic that will be coming to the organizations or from the organizations, and will be intended to go out to the internet. Outbound non-web traffic will be any traffic that will be intended out to the internet that's not going over these web ports. And we can see, for example, in the case of DNS traffic, or in the case of ICMP, for example, or any other kind of TCP connections in other ports. Inbound web traffic will be any response from the internet on a web request, for example, a post message based on a request to a website. We can see more about this. I'll be sharing a couple of articles that talk about this information, just to keep that in mind, or to even keep it for reference in conversations with the customers as well. Here we can see a couple of examples of the type of services that are going to be involved for the inbound and outbound traffic that's going to be executed and enforced by those SMEs. For example, in the case of a GET request that's going outbound, I may not need to enforce things like DLP, while I need to do it for a post message that contains maybe some sensitive information, or that's a file upload, for example. And in the case of any response that's coming back, for example, I can or may need to enforce some of these sandbox or file type control rules, while may not be necessary for anything going outside. Make sense? Any questions with this part?
I got what's probably a dumb question. So the sandbox, how does that actually work? Like, I know what a sandbox is in security, right? But what is it doing here? Is it allowing somebody to actually look at the files?
Well, not someone, but something, right? It's basically what we do is that and sandbox is not something that I will do for everything, right? It will be mainly for things that I may need to access, but I don't fully trust them, or they're still unknown and it can potentially be malicious. So what I want is that when I'm sending a GET request to those websites and they're sending me back a file, I want to take that file from the SME, send it to the behavior analysis node, put it into a virtual machine, detonate that file, either execute the file, try to install it, or just open it up and see what it does. It will basically record if it's making outbound connections, if it's starting any kind of processes or anything malicious, it will be recorded from here. So if it's detonated and we find out it's malicious, the user never get that file, right?
So what's the delay between going to sandbox and being delivered to the user? It's got to be a long time, right?
Sometimes it is, but usually it's just a few minutes. I've seen it in a matter of just a couple of minutes, but I've seen it also taking up to 10, right? So depending on the size of the file and a lot of different things might take longer or less time. But yeah, that's why it's not something that you will do for everything, because it's something that that user needs and fully trusts. Then we can create an exemption for that, or we cannot have a sandbox rule for that kind of traffic, right?
Oh, got it. So you're looking at signatures, and if everything is good, you know it's a good file.
Even before that, because the signatures and that kind of information will be done by the advanced threat prevention.
Yeah,
That's
that's further
where
down in
we
the stack.
that's basically the very end of the line. It's something that I don't have any recollection from, and it's coming from an unknown source. So I want to know exactly what this is before it even gets to the end user, because it may be a variation of an existing threat, right? It's just maybe a 0-day attack or something like that. So we want to make sure that those users are protected from those kind of things.
Yeah, I was just curious because I was like, there's no way this can be real time because that's not real life.
It takes a while, but that's why it's not intended for everything. It's mainly a very small pipe. We'll be talking a little bit more about that, but just as an overview, we always try to go from the highest volume with the lowest risk to the lowest volume with the highest risk. That's where Sandbox will work.
What's the user experience while they're waiting on the sandbox? Does it give some kind of notification?
If they're not aware of it, that's where cases can come from, right? And also, there might be situations where the MD5 is changing every time they download the file. So they just keep refreshing and they're just never getting the file because it's still getting into the sandbox and you're filling up that queue. So when the files are not too big and it's a reasonable size and stuff like that, it's not that bad, and we usually want to intend that for smaller files. When it's outside of that scope or getting into that kind of like limit of the supportability of the file sizes and stuff like that's where you may have maybe a poor user experience, or at least that's where things might need to be put into perspective. Yeah. Yeah. Overall, it's mainly about discovery, because those kind of issues and those kind of things are seen when you're initially starting with this kind of configuration. Similar like DLP. It's usually a lot of false positives that you need to start basically taking those fires out before you can get to the point of getting out that normal experience and that expected delay. But usually it's during that first phase of the deployment where things are getting more painful for the users, at least for what I've seen.
All right, thank you.
Cool, thank you. Now, when talking about firewall, we have two different type of modules. We have the standard and the advanced firewalls. So with the standard license, we have a very basic firewall that allows us to block based on policies in layer 3 and layer 4 information and create FQDN-based allow and block policies. That's basically all that we got from that standard firewall. Very effective, but it's kind of like a lot of manual configuration. In the case of the advanced license, we can create allow and block rules based on network applications. That it's more basically like a merge of different ports, source ports or destination ports and specific protocols that will be making a specific application. We also have the option to create DNS control rules and make use of the cloud IPS prevention, which is used for non-standard ports, for non-web protocols. We also have the option to create destination NAT rules. We don't do source NAT because remember, all traffic is sourced from the SMEs. And this is just a representation of the type of modules that we'll see enforced on the SMEs for the policy enforcement. Once again, I'll be sharing a document that explains this a little bit more in these sections. But overall, what we'll be seeing here is that the request comes first, checks if this is web or non-web traffic, goes through the SSL inspection, and then we start seeing web. By web, we're talking about cloud app URL filtering. Then we have advanced threat protection and antivirus feeds. if we need to enforce DLP rules and the policies. We then send it to the firewall policy for its later evaluation. I may be allowing everything here, but I'm blocking ports 80 and 443 here, which means that the firewall block policy will be blocking my web traffic. If everything is allowed, then we're going to be setting up the bandwidth control rules and sending the traffic out to the internet. When the traffic comes back from that request, we are going to be then sending the traffic back to either the web or firewall module. And if it's in the case of just web traffic, we're going to be enforcing all the actions like sandboxing, for example, or browser isolation, and then send the traffic back to the client. Within the firewall policies, we'll be enforcing either the advanced firewall or standard firewall based on, once again, the actions that they need and the licenses they have. But the SME itself will have both of these accesses there. All right, all right. So I think the banner is right on time, right? We still have a few. Let me see how long we take till. Oh no, we have about an hour and a half, right? So let's do this. Let's get our second break for the day. And when we're back, we'll be almost at the last hour. So we will be continuing and talking about traffic forwarding, and we'll be doing some demos as well. Sounds good? Any questions? Anything else? All good, guys? How you feeling so far?
Yeah, so far so good.
Awesome, awesome.
It's good to be
All
able to
right.
ask questions instead of just going through a book.
Yeah, or a video that just tells you click here, click there. Yeah. All right, all right. Yeah. Thank you guys for that. Thank you. And for the labs, again, we'll be sharing those later today. I'll be sending some unicast emails to you with the information so you can start playing with this. But tomorrow we'll be starting with more hands-on for sure. All right, team. Thank you so much, and I'll see you all soon. Have a good one.
We're doing a 20-minute break.
Yeah, might be extended it to 25. I think we're with good time frame right now. So yeah,
Okay.
we'll be doing about 20. I'll be sharing the timer again. So yeah, you'll have it
All
there.
right. Thanks.
Cool. Okay.
of their undoing. And Nicolae Ceausescu is at a rally in Bucharest. He's on whatever balcony.
All right, team. We're back from our second break. Once again, let's check on the attendance before we resume our call. You may raise your hand, unmute yourselves, or just let me know in the chat. All right, I have 11 hands raised. I have half this quorum there missing. All right, I have some on the chat as well. Thank you, Tim. All right. Let me take on the screenshot. Remember, guys, it's very important to try to be here for most of the session. Okay. Now that we've talked about the architecture of the CIA cloud, now keep in mind, this is the same architecture for each of the clouds that we have in CIA. Because we have Zscaler 2, Zscaler 3, we have now Zscaler 10, Zscaler 1. So there's several clouds, all of them shared the same type of architecture. Before we go into traffic forwarding, are there any specific questions, anything that may not have been fully clear? All good? All right. So let me share back my screen and we'll be taking a look at the traffic forwarding mechanisms. So the first traffic forwarding mechanism that we'll talk will be, I think, pack files. But during this whole session, our objective is that you guys will be able to explain and describe things like what are the pack files and pack servers, what is a GRE tunnel, and what's the difference between that and an IPsec tunnel, the different flavors that we have for IPsec, and how the client connector it's using different forwarding mechanisms for sending the traffic to the CIA cloud. Now, the first one that we'll talk about is pack files. Pack files stands for proxy auto configuration, and this is using JavaScript functions that helps us to determine whether web traffic goes directly to its destination or is forward using a web proxy server. For that, we're going to be seeing a statement like the one that we're seeing in this configuration here, that it's the function to find proxy for URL, and we're going to be using that for URLs and hosts. This allows us to intercept the traffic, and we can then provide a return statement with either direct or proxy, where we'll be defining the specific proxy that we're going to be sending. Anyone might not be fully familiar with pack files that may need a little bit more on what a pack file is. Would you guys let's take a look a little bit more on the admin portal as well, a little bit about this, so
Yes,
we can
please.
check on these
'Cause I'm a
files.
noob.
Cool. All right. That's good. That's okay. Okay, so for example, well, you know that when we're having a testing machine, let's take the Windows machine here, for example, right? So we're gonna be logging out from here. We're gonna take out the client connector from the equation for now, and even the SAML connections, right? So if I'm going here to the proxy settings of the Windows machine, I have two options. I have the option to use a proxy auto configuration file or a pack file, or I can just send everything to one single proxy, right? So this is gonna be telling the web browsers that they need to send to the traffic to that destination. Let's use this as an example first with an explicit proxy, and then we'll jump into the pack file. That hopefully might make it a little bit easier. So I'm gonna be changing this to Zscaler 3 just to make it a little bit easier in the traffic forwarding overview. So in this case, I'm using gateway.zscaler3.net. What this is resolving is the closest data center according to the location of this user. I can also just take the traffic from here, and let's say, for example, that I want to send the traffic to Washington, right? So I'll be using this host name, for example, correct?
And this is manual, right? Yeah, this is your
This is
manual proxy.
manual. Yeah, this is all manual proxy configuration. Yeah. So let me show you here.
Yeah, so you're stuck to that one. That goes down, you're screwed.
Yeah. That's the thing, exactly. If this goes down, then that's it. Everything just fails, right? But let's take a look at this on the web browser real quick. I'm gonna be running the header tracers with the developer tools. You can also use Ctrl F12 on your keyboard to get this panel. And from here, we're gonna be taking a look at the network tab. And let's go to ip.zscaler.com, for example. As you notice here, all my traffic, it's going to the destination 165.225.831, right? If we do an NS lookup for the host name that we just grabbed, it should be resolving to that exact same bit. This is the virtual IP that our traffic will be sending the traffic to. So far, so good.
Yep. I'm
right.
more confused with how and where does it get the pack file information?
All right, we're gonna get to that in just a second. Yeah. So these are the pack files that we have available on the Zscaler cloud. If you go to administration, you go to hosted pack files, and you can see mainly just the defaults, right? I have a bunch of other ones, but let's take a look at a default pack file, okay? So this one, for example, right here, right? So if we see this, it's giving us that find proxy for URL function. There's a lot of things here that we won't be taking a look at just yet. But at the very bottom of all of this, there is a return statement. This is the catch-all, right? All the others are either exemptions that we'll be taking a look in a moment, and will be if you're resolving to this IP, then you're going direct, right? But if none of these criteria are met, the last line, it's sending the traffic using this variable here. So far, so good. This is the first, this is the last, right?
Yep. But let's say I'm not a coder. Luckily, I can understand what I'm looking at here, but let's say I wasn't.
Oh,
Who
the
comes
easiest
up with
way to
this?
see it, the easiest way to see it, in my opinion, or the way that I actually learned a little bit more about this, was using things like, for example, Notepad++ that allow me to see a little bit more of a visual reinforcement. So things like Visual Studio, Notepad++, and I think there's some others in macOS like Sublime Text,
Yep.
that can give you something like this. But what I'm going to is this. Let me show you here. If I go ahead and paste the file here, and I change the language to JavaScript, it now shows me the functions in yellow, and now it's kind of like give me a little more, right? So if you're non-coder, I think this is one of the best options to see it, because it allows you to basically see it with a little bit more of a color coding there. Not sure if that helps.
I assume there's knowledge articles that people can go to on how to write
Oh
this.
yeah. Oh yeah,
Okay.
absolutely. Absolutely. Yeah. They're best
Templates and
practices and a
stuff.
lot of things. Oh yeah, yeah, absolutely. Yeah. Yeah. There's also articles about using pack files with the client connector. because that's where things are starting to get a little bit more complicated. But overall, the basis of what a pack file is and how it works, you can also find, of course, a lot of information outside of just Zscaler itself. And that's all the same for these exact same kind of use cases, right?
Perfect. I think that answers my question.
Cool, cool.
Because
All right.
this right here is what I was trying to dig into.
Awesome. Yeah, definitely. You can just
But is
Google
there
pack
any
files and you'll find a
reference?
bunch of articles and trainings about that for sure. Sorry, there was another question. Did I heard something else already?
Yeah, I was just asking where do I find the sample files?
That'll be on the admin portal, but not yet. I will give you a couple for you guys to see, and we'll be using a few of these for some of the exercises. But once you guys have the access to the admin portal, you will be able to get more free access to all of these pack files. For now, I'll be giving you a few samples that we're gonna be playing with. All right. Okay. So in this case, let's take this pack file now. This pack file is using that gateway variable instead of maybe sending it to a specific proxy hostname. I can also just go ahead and use that hostname and send it there. Let me show you a couple other pack files that I have here. Maybe this one. This one, it's sending traffic to a specific virtual IP, right? Then I have the secondary and the third and the fourth option, and then eventually send it direct if all of them fail. I can either put the IP address or I can put the specific proxy hostname, or I can send the traffic direct to bypass it. All right. Now, let's use that pack file here. Instead of using this option, we're now going to be using this other option, which in this case, I'm just going to paste the URL of that specific pack file. Let me send it here. All right, it took it. There you go. So we're going to pack.zscaler2.net. That is the pack server. And we're checking in the folder zscaler2 a file named proxy.pack. That's what this is going to be requesting. If we get this file here, let me show you also one thing, because that's part of the gateway variable, which we'll be talking about in just a second. But just to show you here, if I go ahead and download this file, you'll notice that now it doesn't says gateway. It actually gives me an IP address. We'll be talking about this in just a second. For now, what I'd like you guys to know is that the pack file will allow us to basically change the same behavior that a manual proxy will do, but with much more flexibility. Now we can create exemptions, even use multiple proxies depending on the destination we're using, and also make sure that we're getting the closest resource available according to our location. Make sense?
Yes.
What pushes this to the machines? If I've got
Uh,
4,000 machines, I'm not going to go flip the lever each
Oh,
time.
yeah, no, exactly, right? Usually, we're going to be using the client connector for that.
Okay.
Yeah. We'll talk about how we do that in that case. But yeah, no, having to do this either with GPOs or things like that, but managing that, it's definitely painful, yeah. For labs, we're going to be doing that a lot. And we're also going to be using a plugin that's pre-installed on your machines. That's called Switchy Omega. This option allows us to create different profiles that will contain different gateways. So instead of going into the explicit proxy, we can just do it with a plugin in the browser as well. Things like Firefox use their own proxy settings too.
That's why nobody uses it.
All right, then this is the flow. When the clients go and download the pack file from the pack server, we get a primary and a secondary data center. Only the primary connection will be used, and if this is failing, then we will attempt to make the connection to the secondary service edge. And as you may notice here, this is only intercepting proxy-aware traffic. That means that not even all 80 and 443 traffic will go through here. Some things like, for example, Windows updates is not proxy-aware traffic. I'm not saying that that traffic should go to CIA, just using as an example. But that kind of traffic, even though it's web traffic, is not intercepted by the proxy. Make sense?
As much as it can. Yeah.
All right. Cool. Yeah, there are applications that, for example, you may use the web browser application and that will be intercepted by the proxy. But if you install the application in Windows, then they might not be using the proxy because there are their own instance. It's no longer using it based on the browser. So things like that, that can end up happening sometimes. When we're using a proxy, the client will always send a client hello, an HTTP connect, sorry, prior to the client hello or to the establishment of the connection. The proxy service on the browser will send this connect message to the proxy, basically telling them the intention to connect with the app. If this is allowed, then we'll receive a 200 OK. If not, we'll receive the end user notification with the block page and then proceed with the connection. Notice how the communication from the browser perspective is not against the actual server like google.com in this case. It's all going through the 165 IP that is the virtual IP of the proxy. All right. Now let's take a look at that on a real scenario or on the web machine before we continue with the bypasses, so we can make it maybe a little bit more helpful on that part, or we can make sure that that part it's totally clear. So right now I have the pack file here. Just let me verify that. There we go. I'm just gonna run Wireshark here. And I'm just gonna go and open up this. And let's go to portquiz.net. You see that it's instantly challenging for authentication because this is a remote user and Zscaler is a closed proxy. So they need to know who is trying to go to portquiz and from which organization so they can enforce the required policies, right? Let me see, user one. Now you notice that I was redirected to the IDP, but that was a redirection that happened from this login.zscaler2.net. This is the central authority. Once the user comes back, then we're prompting with the authentication and the user should be eventually getting to the application. In this case, the application is giving us a 409, right? Which might be an issue with the proxy. We might take a look at that one in just a second. Let me stop this and let's save it as a capture with the proxy. Now we're going to be running Wireshark again. Before we do that, we're going to be turning off this pack file. I'm going to start capturing again. And I want to try going to port quiz again. I do get the page back, or I do get the home page here. And I'm just gonna stop this. All right, maybe let's see just HTTP packets here. This is the one without Zscaler. And we're gonna be also putting this other one there with the proxy. Now, we'll do it with the other one then. Okay, so let's do HTTP here as well. We see a bunch of HTTP connect messages here. Let's see if we can get the one from port quiz. Here's one, and here's the connect message. So let's follow this one. I'm just gonna follow the TCP stream so we can see just that connection there. And I'm also gonna get just this one with the HTTP, okay, with the 200K, and follow the same stream. So just from this capture, you can notice that when we are using a proxy, we see that connect message after the TCP handshake, and always happens through the virtual IP. While we do that without the proxy, we don't see the actual virtual IP, and there is no HTTP connect message. Now, the thing here is that right now we're doing it with and without Zscaler, but this could also be with Zscaler in both scenarios. Because in this case, this client's machine could have a tunneling mechanism that it's intercepting the traffic and sending it to CIA. That is what's known as a transparent proxy, because the browser is not aware that the traffic is intercepted somewhere else. That can be done with an edge firewall or router, or even the client connector can also do a transparent proxy. This is what's known as an explicit proxy, because the browser does know that it needs to send the traffic to a proxy, and it's sending an actual HTTP connect message. Is that clear, Tim? Yes, no, maybe?
Yep.
Yeah, no, that's straightforward.
Awesome.
Yeah.
All right. You can also check on that on the help documentation. Again, I'll be sharing mainly a bundle of some of those, but you can just look up these kind of things like transparent proxy or traffic forwarding, and all of that will give you a lot of different information and details about these kind of things, right? Now let's get into the bypasses. We can define different bypasses for the traffic depending on different actions, either the source IP of the traffic, either private or public. We can do it based on the destination they're going to, either based on host or URL. There are going to be some limitations or some functions that will only work with one or the other. So here are just a few of those type of bypasses based on FQDN. In this case, we're using the domain is. If is going to be the function that we can get for that part. Now, we were talking about this main information and where we can get some of this. My main source, or at least one of the most important ones, is the find proxy for URL. This is going to be giving you a breakdown of all of this. I think it's one of the most complete. Of course, it's the one from them. So that I think it's a very, very useful one. There's another one from Mozilla as well that offers a couple of very good examples. Overall, I think this one provides most of what they're doing, but you can see the functions there, and we can see a little bit more on what is a pack file. So I think this should be the main source for that kind of like introductory level of what pack files are. Now, as we're seeing with these examples, we can use different of these functions for different options, either depending on the FQDN, exempting for a specific server IP address, particular private source IP, or a specific destination with a specific subnet. We saw this in action just a few moments ago, where we can use this variable, and that will determine the CIA public service edge closest to the client. So with this, once the client downloads the PAC file, they will send a GET request to the PAC server. And because we have this gateway variable on the file here, by the moment that that file is provided with the client, this is going to be translated to a specific IP address like 65, 255, and anything else, right? But this will be translated into that IP address that corresponds to the closest service edge according to the client. Now, this uses geo location technology. This uses also, for example, the MaxMind database is part of what we consume to get to the closest data center for the client. If there is a mismatch, then we might end up sending the user to the incorrect data center. That may happen because of different factors, but we can just request the Zscaler support team to update the IP database information and the user to be sent to the expected data center we want. Now, one thing that we were talking about before was this happening behind a single egress IP. At that point, all the traffic will be landing on the same SME. As we notice on the packet captures, everything is going to just one single BIP. So for that, we can definitely overwhelm a SME if we're sending thousands of users with the same kind of flow information. For that, we can use things like the gateway index token, which allows us to load balance between the available IP addresses. That means that a user will be asking to the PAC server for the file, and then we'll get the first virtual IP available. When the second user coming from the exact same source is asking for the same PAC file, they're going to be given with BIP number 2. That is if I want, for example, F1. That will be load balancing between 2 IP addresses. I can have up to 7, which allows me to load balance up to 8 available virtual IP addresses. But this is still a manual configuration, right? If my usage increments, then which one should I be using? 1, 2, which one should that be? That's usually the complicated questions around that. So for making it more dynamic, we can use the FX token. This suffix allows us to dynamically check or load balance the traffic coming from the same sources with multiple available or with all the available virtual IPs that we have. The only caveat that we have, or the only thing to keep in mind to use this FX suffix, is that we need to have the client connector. Otherwise, we are not going to be able to use this option there. It's using also some of the hardware fingerprint information that's gathered from the client connector, and that's why we needed for this to be used. Now, any questions about what this gateway variable does and what helps us with? All right. Now, similar to these options that we were using, we can use other type of variables for the path files. with these variables, we can use things like the source IP, which will be the source IP of the client. That will be allowing us to either define a specific proxy or, as we were saying before, direct a statement to bypass the traffic. In this case, they're sending it to another proxy, 10.84.0.188. This could be a virtual service edge. Now, why would that be necessary? Any idea of where is the VSC or what is even a VSC?
Sounds like a load balancer.
It kind of like does that too, but yeah, well, we're familiar now with what a PSC or public service edge is, right? Which is the one with the load balancer, the SME, and things like that, right? But it's the node for Zscaler. The VSC or virtual service edge is an option that we can offer the customers to kind of like have a virtual instance that extends the scope of the cloud just for that customer. Why will that be necessary? For example, source IP restrictions with certain applications. When I'm connecting to a specific app, sometimes they expect to have a source IP whitelisted to be able to access the app. And if we're using a service like Zscaler, then it may be a lot of different IP addresses, and they may not allow you to add that many ranges there. So for that, we can have these kind of options, all along with others as well. But it kind of like gives them a more local path while still using the ZIA service. Now, similar to the gateway variable, we have the country gateway variable, which allows us to connect to the clients within the country of origin. This is particularly useful when we have cities or locations that are close to other countries and may have some language barriers. For example, cities that are too close to Canada or Mexico that may end up having some pages in French or in Spanish. So even though that might be the closest or the most healthy available node, I may still have to comply with those language barriers, right? So I can define this kind of configuration. So by the time that the PAC server tries to deliver a specific BIP, it takes those parameters into consideration. If we're using the country gateway variable, but there is no data center available on that client's country of origin, then it falls back automatically to work as a regular gateway variable. For example, me in Costa Rica, there's no data centers for Zscaler here in Costa Rica, not even in Central America. So if I try to use the country gateway variable, I'm most likely going to be redirected to Colombia, Mexico, or Miami. Now, here you're seeing that we're using two different country variables, right? We have the country gateway variable in the return statement, and we have also here another variable called country. These variables are used a lot on the PAC files because it allows us to make some dynamic actions without much of CPU usage or without having the browser take longer time to parse a lot of information by doing multiple lookups. So in this case, for example, this is a variable called egress IP, and it's using this variable information. In this other case, we're using the variable name country. This can be any name we want, and this is the variable that we're using. So basically, if when the customer downloads the PAC file, it says Canada in here, then this statement will be true and this proxy will be given. Make sense? Yes, no, maybe? Maybe we can do it maybe with an example here.
I think it makes enough sense to me, but I'm not speaking for everybody.
All right, everyone else? So far, so good with the PAC files?
Yeah.
Yeah.
Yeah,
Awesome.
don't want to use them, but yep.
Yeah, I've been there. All right, so, and we can do it for multiple things. In this case, they're using the country gateway. In this case, they're combining multiple statements. So now it's not just about the country, but it's also if you're going to a specific destinations, right? As you see, we're using the logicals and or as with any regex as well. So we can combine multiple statements and multiple criterias. We also have the option to have a subcloud. A subcloud, it's a basically a custom rotation for the customer that may include the regional surcharge nodes that we were talking earlier, and also private service edges that may have, and or a custom rotation because of a particular problem. As an example or a real life use case of a subcloud, I once had a situation with a customer where we on Zscaler were having a performance issue with one data center because it needed to add more capacity at that time. We're talking about 3, 4 years ago. So that data center was having problems, and the customer had users that could get elected to go to that data center because of the country or because of the gateway variable. The problem that we were having was intermittent. So it doesn't mean that they were always having the performance issue, but when that kicks in, they will start having the worst experience. So we wanted to avoid using that data center. So what we did is that we created a subcloud that contained all the data centers from the USA, in this case, because that's where the users were from, except for those specific data centers or the data center that was having problem. We use that subcloud on the gateway statement or the return statement of the pack file. And in that way, we were making sure that they were getting to the closest available, but without taking that faulty DC into consideration. And that is achieved with some of these variables that we were talking about before. We can use the subcloud with the country or the gateway variable and the FX as statements for any of the options that we may need. Here are some of the public APIs that you can use for checking different information for the customers. For example, you may see what will be the gateway statement from this particular IP address. No, I didn't put the cloud name. That should be important, right? There we go. So based on this IP address, I will be getting connected to the data center in Chennai, and then so on and so forth for the other two. If I'm using any other IP, like for example, let's say my current public IP address, let's see, should be this one. By default, let's see where I should be connected to. I should be connecting to Mexico, but instead of that, I'm connecting to Miami. You see? That's because there's got to be some custom configuration in my corporate Zscaler client connector that's sending the traffic to Miami instead of to Mexico. And same thing with the subcloud names and with some of the other parameters for the coordinates. All right. Now we have here a couple of exercises that I like to usually make it into a couple of groups. So we can then share the experience between each other. I don't think we'll have enough time for talking it out on the call, at least not today. So what we can do is that we're gonna be doing the exercise during this last half hour, and tomorrow, one person or anyone from the groups will be basically helping to get that part done. We have quite a forum during this session today. I'm wondering how we can divide it because we're going to be talking about groups of 12, which still a little large, but we only have two exercises for this option. So I'm wondering, yeah, I guess we will be doing that right now. Let me see if I can create the breakout rooms anyway, because that is not my session. So let me see. Okay, no, plan B. It seems like I don't even have the option to create the breakout rooms here. All right, then in that case, I guess we're gonna have to take our time with some exercises right now. Let me give you the pack file that this is talking about so we can have all of these for you guys. Give me just one moment and I'll be giving you the pack file that we'll need to troubleshoot. What we'll be doing is that I'm gonna be asking then one person to share their screen and we'll be helping you out to get that resolved. Okay, just bear with me here just a moment. I'm gonna be sharing the file on the Zoom chat. Just a second. You can open this file with Notepad++, with any option you may want, right? All right, so let's first take a look at this problem scenario and let's see what this issue is all about. So in this case, the customer is using pack files to route the traffic or their internet traffic to the Zscaler cloud using this gateway variable. Remember that this gateway variable should be providing us with the closest data center according to the customer's location. But instead of that, they are being routed to a data center in Dallas. They expect to connect to the DC in San Jose, California. So we need to verify this pack file and analyze what could be causing that they're being sent to Dallas instead of San Jose, or if we can maybe see something and plan any kind of next steps ahead. Okay? Now feel free to go through the pack file. I'll give you just a couple of minutes to browse it a little bit. If anyone wants to share or wants to ask anything in particular, feel free to raise your hand and we can start from there. But I'll give you what, 2 minutes will be okay just to quickly look at the pack file there. Let's make it 5 just to give you some time, okay? I'll make it 5 so you guys can do maybe some research about it and then I'll start asking around. Sounds good?
Where's the where is the pack file? Or is it in the
I
chat?
I
Okay.
pasted on the Zoom chat, should be there.
Got it.
Is DFW1, is that supposed to be Dallas?
Maybe, yeah, we can check on the config page.
Yeah, I think that's the problem then.
There you
I
go.
think I
Yeah,
got it.
you're on the right track.
I think it's because we're manually setting that egress IP.
All right. You wanna share and I can help you out looking or how we can confirm that.
Sure. So this is what I latched onto here. And this says, if it matches, then return this proxy.
All right. So one thing here, just to let you guys know, this pack file itself, it's just an example. It's not actually functional. If you try to use that pack file on somewhere else, it's actually gonna be failing because it has a few syntax errors there. So let's do a couple of adjustments there. Now, you see that right after every variable, there should be the word bar, right? And this one that's called egress IP doesn't have it. So let's add that to the pack file. Let's add bar and space.
Didn't even catch that. No, it's not a tab though.
It doesn't matter. It can stay there. It doesn't have to be within the same exact position. That's totally fine. Now, another thing that we need to be aware of or be careful is that the variable it's case sensitive. In this case, I think we're good, but it's just one thing that we got to be aware of. If I put here egress IP with lowercase, then this variable is not working, right? It's just one thing to keep in mind there. And this bracket here, the last one, we need to get rid of that one. That one is also not part of anything.
Oh.
You can get rid of this the bracket.
Yeah, I can bring it up in Notepad if that's better.
There it goes. So you see it's basically up to the
Oh,
curly
yeah.
bracket. That one needs to go. Yeah. All right. Now let's just have a quick look at it. And it looks good.
Yep.
So
close.
yeah. Now, all right. Time's up. There you go. So now that we have the pack file with the correct syntax, let's copy that pack file. Let's copy the whole file, and we're gonna be opening up a Google Chrome or any browser that you want, and look up for pack tester. We're gonna be using an online tool, and we can see or check how we can verify this.
What is it called?
Just look for pack tester. I think it's Thorsten something.
Oh, just
But if you
Google
look
it.
pack tester, it should be the first option there. It's like Thorsten.pm, the name of the tool. Yeah, that's the one. Now you can erase that pack file, or oh no, that's the one. That's the one. Okay, we're good.
Yep, this is ours.
Okay, perfect. Now, if you try to go to example.com, just do find rule. We should see what's the return statement here. And here it's telling us that it's DFW, right? So this pack file is sending the traffic to this proxy, right? That's the very last one that we see with the gold one, and everything else shows under false. It doesn't even get to the last one here, right? That's 16. So let's now go ahead and modify this and put this IP address, this 72.217. Let's put this IP address in here.
And this should send
No,
us
no, the other way around was it? It was the other way around. It was put the 7 IP in this pack file. It was just the pack file, the one we need to configure, the modify. Yeah.
So you want to put this in here.
Exactly. And now you do find rule, you notice that we're getting the proxy because now the egress IP variable that we did is no longer a match, right? And this is created or this is added when the customer downloads the pack file, right? That means that when that client downloaded the pack file to the pack server, the egress IP was this IP. And they have an explicit line telling them, hey, you're going to be sending that traffic to Dallas.
Oh, so it works for him and not anybody else.
It might be, yeah. Or basically, we want to see why is that they're having that as the egress IP. It might be that they're having a GRE tunnel on top of the traffic that's causing that, right? Because this looks like a Zscaler IP address as well. So basically what happens here is that when the client sends that GET request for the pack, that pack file, we're seeing them as coming from this IP. And because that is matched on the line, the traffic is all going to Dallas. So it's not actually a misconfiguration. The pack file is doing what it's supposed to be doing. We just need to find out why is it that we're doing that for him. Either something on their network or something that should be for a different source IP. Or maybe the line is completely needs to be gone, but that'll be their decision at that point. Make sense?
So the issue is that the source IP doesn't match, or other users doesn't match the same source IP pretty much.
Yeah, well, in this case, it's because they are matching that IP and they shouldn't be matching that IP, right? Why are they matching it? That's a conversation further down with the customer, right? Because we need to find out why is that their egress IP. But the pack file itself, it's doing that because we're telling them to do that when we see that as their egress IP address.
Yeah, so the way I understand it is this is saying you're looking for this. If this is contained in there, then you're going to set this. But since we change the IP address to be this, it doesn't match. So then it returns this instead.
Mm-hmm. That's
Is
correct.
that okay?
That's correct. And again, the thing with the pack files is that as with any code, you can be as organized or as messy as you want, right? So ideally, this specific line should be on the top of the pack file with the other variables, right? Because if you scroll up there to the very top of here, you see that I have a variable called private IP, and it's using the regex for some things. Then I'm having another variable that's called resolved IP, and it's used a DNS result for their own host, and so on and so forth. So this is where egress IP should be because I have my pack statement, I have my variables, and then I have the bypasses. Everything should have some best practices and correct syntax, at least to have some sort of order. Same as, for example, the comments, right? If you check on that last line, there's no comment there. So we don't know what this is for. We have it for the default. You see that the default does have a comment. But this line, these two lines here, they don't have any comments. So we don't know what they're for. So even having the best practice of commenting everything that you're going to be doing there, it's also going to be helping out understanding why it's doing what it's doing sometimes.
So what's this here? Is this the primary gateway and the secondary gateway?
Yeah, that's correct.
And then if that all fails, then just go direct.
Correct.
Okay. Simple enough.
Awesome. Yeah. Excellent. Thank you so much for sharing there, Michael. And I hope, guys, the exercise, it's helping out understand a little bit more how pack files may work. All right. Anyone else having any issues with this or wants to maybe practice or do things a little different? Just want to make sure that we have the concept clear. Don't be shy. Remember, there's no dumb questions, guys. This is a safe environment. By all means, go for it. All right. Yes, we're all good. Okay. Now, in this other exercise, and this will be a quote unquote homework, you can use the sample. Let me give you the one from the URL. Let me see if I can get it here again. I don't think I share it, so let me share it also from here. Also, the slides have the information there, but what I want to share with you is the pack file, or at least a default pack file, so you can write on top of that one. Let me just get this ready here. I'm gonna give you the URL for the default pack. Maybe here. Yeah, this is the one. Let's use this one. So the intention with this exercise, and again, we're gonna do it as a let's say some sort of homework, so you guys can practice this a little bit more, and we can have it as a follow-up conversation tomorrow when we begin. And the idea is that we create a pack file that is bypassing the traffic that's going to CNN.com using a wildcard. And also, they have to come with a private range of 172.16.00. Feel free to go ahead and try it yourselves. There's also an example of this on the presenter notes, so you can just go for it and look it up. But my main objective with this is that you try writing that down and that you understand what it's doing and that you can test it out. All right. So once again, give it a try during the next few hours today, tomorrow morning, once you rewatch the recording again, if you want to. And tomorrow morning, we'll be talking about how to achieve this behavior and practice a little bit more with pack files before we jump into GRE. Now, one thing here, team, sometimes we may take a little more or a little less with some topics. So it's expected to not necessarily have everything within one single day. There's going to be days where the content will be shorter. So by all means, don't worry about that part that much. Beyond that, what I like to make sure is that you guys have enjoyed the session so far. We still have 4 more days to go, and that you are feeling comfortable and clear with the information that's being provided. So how's everything going?
So far, so good.
Yeah, doing good.
Good back and forth.
Awesome. Excellent, team. Yeah, feel free to ask questions. Again, that's what makes these sessions richer. The interaction and the conversation and the thinking outside of the scope will be always bringing some new perspective into things. I always learn new things from the boot camps, from those kind of feedbacks. So that's always more than welcome, guys. Feel free to speak up. This is your session, okay? But for now, I'll just give you guys 10 minutes back. Thank you so much all for your time and for your attention. Tomorrow we'll be continuing with more content, and I'll see you all tomorrow. Have a good one. Have a good rest of your day or night.
Appreciate it. Thanks for the session.
Thank you.